Hypothesis test for two sample problems. Example. In a study of the effects of stress on behavior in rats, 71 rats were randomly assigned to either a stressful environment or a controlled environment. After 21 days, the change in weight was determined for each rat. The table below summarizes data on weight gain. Test the null hypothesis of no difference between the two group means against the two-sided alternative at 0.05 significance level. There are two groups here, alcohol and placebo groups, and sample sizes are 20 and 51 respectively. Sample averages are 2632 and sample standard deviations are 13.416 and 14.283 respectively. First thing we need to decide hypothesis, null and alternative hypothesis. Before we decide that, go back to the problem and read the sentence, test the null hypothesis of no difference between the two group means. Let's take mu1 as a population average of alcohol group, mu2 as a population average of placebo group. If there is no differences, then what will happen to the mu1 and mu2? Mu1 and mu2 should be equal, should be the same values. Mu1 minus mu2 should be equal 0. So we need to check no difference between the two group mean. Then what should be the alternative hypothesis? Therefore, mu1 minus mu2 not equal 0. Therefore, we write here mu1 minus mu2 equals 0 versus mu1 minus mu2 not equals 0. Then we need to decide test statistic. We know we have sample standard deviations and x bars. So therefore, we know two sample t-test. It is x1 bar minus x2 bar divided by s1 squared over n1 plus s2 squared over n2. So we know all the values. So we can get t naught equal negative 1.664. Then need to find the p-value. To find the p-value, we need the degrees of freedom. Yes, what is the minimum sample size? It is 20 of the alcohol. So therefore, 20 minus 1 equal 19. That is the degrees of freedom. Now we know the degrees of freedom and we know the t naught. So we can find the p-value. Right. Degrees of freedom is 19 and we need to find the negative 1.66. T distribution is symmetric. Therefore, we should look for the positive 1.66 in this line. Can we find the positive 1.66 in this line? Actually, no. 1.664 should be in between 1.328 and 1.729. Then go back to the alternative hypothesis. What is the alternative hypothesis? Mu1 minus mu2 not equals 0. That means it is two-sided. So pick the two-sided one. Once you pick the two-sided one and get the p-value corresponding to those two values, those are 0.20 and 0.10. Therefore, we can find the range of a p-value. It is 0.10 to 0.20. Again, we cannot find the exact p-value, but we can find a range for the p-value. Now we know the range for the p-value. What can we understand from this range? We know the minimum p-value greater than 0.1 and maximum possible p-value should be less than 0.2. Then we go to the decision. How do we get the decision? First, check alpha. Alpha equal 0.05. Here we know alpha 0.05 less than 0.1. That means p-value should be greater than 0.05. Why? We know p-value should be greater than 0.10 and 0.10 is greater than 0.05. Therefore, we know alpha less than p-value. So how do we get the decision? we reject S0 if the p-value less than or equal alpha. Actually here we have opposite, p-value greater than alpha. Therefore, S0 is not rejected. S0 is not rejected mean it is accepted. In other words, mu1 minus mu2 equals 0. It is right. Therefore, what is our conclusion? We can agree with H0. That means mu1 minus mu2 equals 0. Then we can say mu1 equals mu2. That means there is little evidence in support of conclusion that mean weights of rats in stressful environment differ from those of rats without stress. Thank you.